Okay, going to be working 2.6, implicit differentiation. Very, very important topic. What this section allows us to do is take derivatives of equations that are not functions necessarily, or things where we cannot solve explicitly for y. So let's look at number 1. They give us 9x squared minus y squared equals 1. And part A is they want us to find y prime using implicit differentiation. So what we need to understand is this means the derivative of y with respect to x. So we're going to be treating y as if it depends on x, and x is really going to be our independent variable. So the way we do this is we take the equation and we take the derivative on both sides of the equation, in this case with respect to x, since it's our independent variable. So I'm going to take the derivative with respect to x on the left side, and I'm going to take the derivative with respect to x on the right side. Now, the derivative of a difference of two terms, I can just take the derivative of each one. So that becomes the derivative with respect to x of 9x squared. And then minus the derivative with respect to x of y squared. And that must equal the derivative of a constant, and we know the derivative of a constant is 0. Now, because x is the independent variable and we're taking the derivative of a function that has x in it, this is going to be our standard derivative. We're going to use the power rule here. We have a constant in front, so the derivative of this should just be 18x. Now over here, this is where we run into the difference. Here we're taking derivative with respect to x, but our variable is y, and so we're going to act like y is some function of x. So when we take the derivative of this, we have to apply the chain rule. It's very important. We are first going to use the power rule. The 2 is going to come out. We get 2 times y to the first power, which I don't need to write. But then we have to take derivative of what was in here, okay, which would be the y. And what is the derivative of y with respect to x? It's not 1. It's the derivative of y with respect to x, whatever that is. And then that must equal 0. And we need this piece to come out because that's what we're trying to find. And if you take a derivative implicitly and you never see this piece show up, then something's wrong. All right, so at this point we need to solve for this. So what I'm going to do, I'll just move this whole term to the other side. Just add it to both sides, so we'll get this. And then to get this by itself, I'll divide both sides by 2y. Dy dx is this. Now that simplifies a little bit also. And we get 9x over y is dy dx. And that's it. Now we could go a little further. Normally when we take derivatives, when we had something like, y is equal to x squared, the derivative of this would be 2x. Our answer usually just had x in it. Here, our answer has x and y in it. So what I could try to do, and it won't always work this way, is I can try and solve this for y. So let me take this and just move things around. I'm going to move this to the other side, and I'm going to move the 1 to the left side. And then I can take the square root. So if I take the square root, remember I have to do plus or minus. 9x squared plus 1 equals y. And now when I look at this derivative, I can replace this y with this. But notice we're going to get two different answers because we have a plus or minus. And, sorry, not. This is dy dx. It's telling us that the slope of our tangent line at any given point is going to be 9x over plus or minus 9x squared plus 1, take the root, right? And that's because when we draw this curve initially, it is not a function. So it's going to be something like a circle or an ellipse or something like that, or it's just not it is not a function, fails the vertical line test. So if I draw my x and y axes somewhere in here, then if you go out to some x value, the slope of the tangent line, there's two different answers. There's one up here for that tangent, and then there's one down here for that tangent. And this would provide you with both of those answers. So that's first part. Part B. Okay, so part B, what they want us to do is they want us to solve for y and take the derivative. Now we already did that. So for part B, let's solve this equation for y, which gave us, remember, two answers, and then find the derivative. So let me go and do this, and what I'm going to have to do is two different cases. I'm going to do the plus and the minus. So I'll do the plus here and put, or we can do y equals negative root 9x squared plus 1. Now all they're doing for part B is just showing you that if you do it the other way, which is this way, we should get the same answer. So I don't need the plus here. Now the derivative of this, which I'll write dy dx, I could write y prime, is going to be chain rule. We have an inside function and then the outside function is the root. So the derivative of the root of something is 1 over 2 roots of that something. And then times the derivative of what's inside. The derivative of what's inside is 18x. And notice that the 18 and the 2 reduce out, you get 9x over root 9x squared minus 1. So that's the derivative there. Now if we do this one, the only difference is we have a negative. So when we take the derivative, we get, that negative would come along for the ride, we get the same answer, but negative 9x over root 9x squared plus 1. If you check, that's the same answer we just had when we did implicit differentiation. They had the plus or minus down here, which was the same as putting a plus or minus up here. So it gave us the same exact two answers. So that just verifies what we already know. Yeah, for part C, I already did that. So part C said verify that they were the same answers by replacing y into the answer for part A. So I kind of did that when I did part A already. All right. Let's look at number 2. So for number 2, same instructions, 2x squared plus x plus xy equals 1. So I'm going to take the derivative implicitly for part A. So I'm going to take derivative with respect to x of 2x squared plus xy, and then equals the derivative with respect to x of 1. Now the right side's easy, that's just 0. You know what, I'm going to give myself a little more room, so let me do that in a minute. Here I take derivative of each one of these with respect to x. So I'm going to show a lot of detail here since this is only the second problem. I can break it up. Okay, so since there were 3 terms, I can take derivative of each one. Since I'm differentiating with respect to x, and this is x, has x in it, this is just your standard derivative. That derivative of that would be 4x. Plus, same thing here, derivative of x with respect to x, this is just a 1. Plus, now here's where things get a little bit tricky. We have the derivative of a product, right? And one of these is y, which depends on x, but obviously is not x. So when we do this derivative, we're going to have to apply that little chain rule on that part. So let's just go through it. First, we have a product. So I'm going to apply the product rule. This is going to be the derivative of the first part. Let me write it this way. I'm going to use a slightly different notation. I want the derivative of the first one, right, times the second one. I'm doing product rule on this, plus the derivative with respect to x of the second one times the first one. So there's your product rule on this. equals the derivative of a constant, which is still 0. Now this is 4x plus 1. That's this. And then now, what is the derivative of x with respect to x? Well, that's just 1. So we get plus 1 times y. And then plus, what is the derivative of y with respect to x? Well, that's what we're trying to find out. dy dx, that's what we're looking for. But then times x, and then equals 0. All right, now I can rewrite this as 4x plus 1 plus y, just changing that to y, plus dy dx times x equals 0. All right, now I need to solve for y prime, or dy dx. Now if I solve for that, first thing I'm going to do is isolate this term. So I'm going to move all the other stuff to the other side. This will just be all those over there, just negative 4x minus 1 minus y. And then I will divide both sides by x to get rid of the x on the left side. So when I divide by x, see if I divide that by x, I get negative 4. Divide that by x, I get negative 1 over x. Divide that by x, I get negative y over x. So that is our implicit differentiation completed. Now I will go and replace this y in part C. Okay, so that's our implicit differentiation. Now they want us to do it without implicit differentiation, so they want us to actually solve for y first before we take the derivative and make it an explicit equation. So I'm going to start over here. I'm going to move everything except this xy to the other side. So it'll become, how about we leave the one there, 1 minus 2x squared minus x. So this and this one over to the right. I'm going to divide through by x. So when I do that, I get 1 over x minus 2x minus 1. And I'm going to take derivative of this. Now remember that this is the same as x to the negative 1. That's this. Minus 2x minus 1. I only did that because it'll be easier for me to take that derivative. And now I take the derivative. The derivative, y with respect to x, is, okay, power rule here, negative 1. Or, yeah, I won't put the 1. X to the negative 2. And then derivative of this is just minus 2. And then derivative of negative 1 is 0. So there it is, which is, you could write that as negative 1 over x squared minus 2. So there's our answer. Now, these two do not look the same. So what they're saying in part C is, hey, this one just has x's in it, right? This one has x's and y's. So let's go back and replace that y with whatever it is. And I had solved for y right here. So I'm just, part C, I'm verifying. I'm going to rewrite this equation, and I'm going to do it right up here. dy dx equals negative 4 minus 1 over x minus now y, which is this right here. So I'm going to write 1 over x minus 2x minus 1, that's y, over x. Okay, so y over x. And now what I'll do is I'll actually divide. So remember, this is x over 1. So I can multiply by the reciprocal. So I can come over here and I can multiply by 1 over x. And then just pass that through here, here, and here. So what would happen if I do that? I would get negative 4 minus 1 over x. When I go here to here, I get minus, I'll put it in parentheses, minus, and then whatever I'm going to get here. So here to here, I get 1 over x squared. Here to here, the x's cancel. I get just minus 2. Then here to here, I get a minus 1 over x. And now let's distribute that negative through. Negative 4 minus 1 over x minus 1 over x squared plus 2 and plus 1 over x. And this 1 over x and 1 over x cancel. And you get negative 4 and positive 2, that's negative 2. So that would give you this negative 2. And then minus 1 over x squared minus 1 over x squared. So they are, in fact, the same answer. But the thing was, in order to prove it was, we had to replace this y right here with what it was, which means we had to be able to solve for y. And in the first two examples that they give you, you can solve for y. but in general you can't. And so you just leave your answer in terms of both x and y, like we did initially. All right. Okay, let's look at number 4. So now we just get to, they just want us to do implicit differentiation. They don't want us to do all those different parts. So 2x cubed plus x squared y minus xy cubed equals 2. And we want to find dy dx. So I'm going to take the derivative on both sides with respect to x of 2x cubed. Now there's 1, 2, 3 terms, so I'm going to do this a little faster. I'm actually going to write it out, split it up now, like that. And then I'll put minus derivative with respect to x of xy cubed, then equals the derivative with respect to x of 2, which we know is going to be 0. All right, now this expression right here just has x's in it. So I'm just going to do a standard derivative because I'm differentiating with respect to x. So that's just going to be 6x squared. No big deal there. This one, on the other hand, has x's and y's, and I have a product right here. So I need to do the product rule, which would mean I need to take derivative of the first one times the second one plus the derivative of the second one times the first one. So this right here is just this piece right here. Then I need to do this piece, which is the derivative of another product. Notice I have a minus out there. So when I do this, I'm going to go minus, and then let me do the product rule. Because I'm going to subtract whatever this is. So if this turns out to be 2 terms, I have to subtract each term. So product rule says derivative of the first times the second plus derivative of the second times the first. So derivative of the first times the second plus the derivative of the second one times the first, and that would finish up my product rule, and then equals derivative of 2, which is 0. All right, we can start doing some derivatives now. All right, this will be 6x squared. All right, derivative of x squared, because x is the only variable there, and it's with respect to x, is just your standard derivative, so 2x, but I still had times y, so 2xy. Plus, what is the derivative with respect to x of y? Well, again, y depends on x, that's what we're assuming. So that's going to be dy dx. That's good, I want that, that's what I'm trying to solve for. But then still times x squared, then minus, in this bracket, the derivative of x with respect to x, that's just 1, but then times y cubed, so I'm just going to put y cubed, plus, now, the derivative with respect to x of y cubed, there's no x's in here. So we're going to do power rule, but we also have to remember to do chain rule because we're assuming y depends on x. So derivative of y cubed is going to be 3y squared. That's the standard power rule. But then chain rule says times the derivative of what was in here. And the derivative of y with respect to x is dy dx. So what we're trying to solve for has actually appeared twice. And then I have to finish up, tack on the x next to that. Close it off, equals 0. All right, well, keep going here. Clean this up. I'm going to distribute through with that negative, and here's what we'll have. We have 6x squared plus 2xy plus, I'm going to write it this way, x squared times dy dx. I just changed the order of multiplication. Distribute this through, minus y cubed. Distribute this through, and watch the way I write this. Minus 3xy squared times dy dx, then equals 0. So what I did was the negative distributed, made that a minus 3, and then I put the x in front of the y squared, and then put the dy dx at the end. All right, the goal, remember, all right, the goal was to find dy dx. We need to find out what it is. And right now, dy dx appears here and here. So what we'll do is we'll first isolate the dy dx on one side of the equation. So anything that has dy dx in it, this term and this term are going to stay on this side, and everything else is going to go the other side. So I'm going to have the entire thing, x squared dy dx, it's multiplication. I'm going to have minus 3xy squared dy dx. Now equals, now let's move everything else to the other side. So this goes to the other side, becomes negative 6x squared. This goes to the other side, negative 2xy. I've got that. I've already done that. This one goes to the other side, plus y cubed. This one's already on the left side of the whole thing's there. So that's it. And now that we've isolated the dy dx terms on the left side, we can do a GCF, greatest common factor. We can pull out or factor out a dy dx and be left with the x squared's left here, and over here the minus 3xy squared, and then equals this side, negative 6x squared minus 2xy plus y cubed. And then finally, we can divide this whole thing out on this side and divide it on this side, and when I do that, I'll get dy dx equals negative 6x squared minus 2xy plus y cubed all over what we divided out, x squared minus 3xy squared. There it is. We have solved for dy dx. Now keep in mind, what's important here and what's different from the previous problems is in the previous two problems, we were able to go back and like solve for y if we wanted to and then replace these y's with that answer, but you will not be able to solve for y easily here. So our answer is going to have x's and y's in it. And the idea here, and I'm sure I talk about this in class, is that if this curve is not a function, it fails the vertical line test, then in order for me to talk about the tangent line, let's say at this x value, it could be here, this tangent line, or it could be this one. And the only way to know is for you to also give me the y coordinate. So if you give me the x coordinate and the y coordinate of that point, then we're talking about this line. If you give me this x coordinate and that y coordinate, which is different y coordinate than up here, then the slope will be this. So notice that the slope of the tangent line depends on both, not only the x you give me, but the y also needs to be given in order for me to be able to determine the slope of the tangent line. So it kind of makes sense that you would need both the x and the y in order to get the answer. All right. Let's look at, I think 5 you can do on your own. Let's do number 7. Y cosine x equals x squared plus y squared. I'm going to try and go a little faster through this, all right? We want to find dy dx, and that's the instructions here. So I'm going to take the derivative on this side, and I'm going to notice already I have a product. I have y times cosine x. So I'm going to have to take derivative using the product rule here. This one, I have two different terms. I can take derivative of each one. So I'm going to try and do this product rule right away. It's going to be the derivative of the first one times the second one plus the derivative of the second one times the first one. Okay, there's your product rule on the left side. This must equal the derivative with respect to x of x squared plus the derivative with respect to x of y squared. I can do those separately because there's addition. And now I come back over here. What's the derivative with respect to x of y? Well, that's dy dx. That's what we are looking for. Times cosine x plus, what's the derivative with respect to x of cosine x? This right here is its own function. It has just x's in it, so this is our standard derivative. Derivative of cosine is negative sine. but then still times y. And then on the right side, standard derivative, because I have x's in both places, so this is just going to be 2x. And then plus, this is not a standard derivative because you have x here and y here, so power rule first, 2y, but then times the chain rule, which is derivative of what's in there, which is dy dx. And so now you can see that I have a dy dx in this term, I have a dy dx in this term, and I need both of those on the same side of the equation and everything else on the other side. So what I'll do is make sure I'm recording. Okay. I'm going to leave this one here, and I'm going to bring this one to the left. So it'll be dy dx cosine x times cosine x. And then I'm bringing this one over. It was plus, so it's going to become minus. So minus 2y times dy dx. And that's everything on the left side. Now this term needs to come to the right side. So I already have a 2x here. And since it's a minus, right, when it comes to the right, it's going to be a plus. So I'm going to say plus y sine x. And I just put this y out in front because I didn't want to make it confusing and you think that the x's, or the y and the x are together inside the sign. All right, that's it. Let's now check. We've got dy dx here and dy dx here, so let's factor it out as a GCF, greatest common factor. I will be left with the cosine x that was here, and then minus 2y. And then over here I have 2x plus y sine x. And then I will divide both sides by this. So my final result will be dy dx equals 2x plus y sine x over cosine x minus 2y. There we go. All right, let's look at number 8. I only have about 10 more minutes. But this is a good problem. Cosine x times y equals 1 plus sine y. All right, so let me write this down. I want the derivative of the left and the derivative of the right. So I want the derivative with respect to x of cosine of xy. This must equal, since this is two terms, the derivative with respect to x of 1 plus the derivative with respect to x of sine of y. Now, I'm going to do the right side first, all right, because I think it's a little easier. Oops, I forgot my parenthesis there. The derivative of a constant is 0. Now, the derivative of sine of y, this is x, this is y, so it's not going to be your standard derivative. What we do know is that the derivative of sine of something is cosine of it. So I must do chain rule. Cosine of y first, then times the derivative of what's in here. And so what is the derivative with respect to x of y? Well, that's just the derivative. I'm sorry, what is the derivative of y with respect to x? It is dy dx. So you see how that works. Derivative of a constant, 0. Derivative of sine of something is cosine of that something times the derivative of what's inside. What's inside is y. The derivative of y with respect to x is dy dx. So that's your right side. Now the left side is a little bit trickier because you're trying to take derivative of cosine of a product. Right? So first, what's the derivative of cosine of something? Well, it's negative sine of the something, and the something for us is xy. Chain rule says times, now what's the derivative of what was in here? Well, there you have a product rule. So I'm going to say in parentheses, I'm going to set myself up for the product rule here. And doing the product rule on this, it's going to be the derivative with respect to x of x, so that's the derivative of the first one, times the second one, plus the derivative of the second one, which is derivative of y, times the first one, like that. So make sure that makes sense to you. Derivative of cosine of something is negative sine of the something, chain rule, times derivative of what's inside, which is a product rule. So here's your product rule in that piece. And this is going to be negative sine of xy times, in parentheses, the derivative of x with respect to x, just 1. 1 times y is y. Plus the derivative of y with respect to x, that's dy dx, that's what we're trying to find. And then times x. And then equals the right side, which is just cosine y times dy dx. All right, I have my dy dx here and I have a dy dx here. I need to get those together on one side of the equation. But this dy dx is trapped in this parentheses. So I first must distribute that negative sine xy through. Got to do it here to here and here to here. So watch how I write this. When I multiply this times this y, I'm just going to slap it in front. So minus y sine of xy. All right. Now when I go here to here, this stuff right here, I'm just going to slap it in front. So minus, it doesn't really matter how I write this. I'll just write dy dx times x times sine of xy. So I kept the negative, right, because it was negative here. And then I just put these two factors in front of the sine xy. And now I've distributed, there's no more parentheses, equals cosine y times dy dx. Now I can get my dy dx terms on the right side, or on the same side of the equation. In this case, I'm going to move them to the right because this one's negative. So if I move it over, it's going to become positive. So the left side is negative y sine xy. And the right side is this term, cosine y times dy dx. This whole thing came over, plus dy dx x sine xy. And notice that both of these terms, this term and this term, both have dy dx in them, and I can factor that out. So I'll have negative y sine xy equals, pull out the dy dx, and when I pull that out of this term, all I'm left with is cosine y. When I pull it out of this term, I'm left with plus x sine xy, sine of xy. All right, and now that I almost have it isolated, I'm just going to divide this through on this side, and that will be my final result. So when I divide this on that side, I get negative y sine of xy over this whole thing, cosine y plus x sine of xy, and that must equal my derivative, dy dx. There we go. All right. I want to say I have time for one more. Let me try and do 10. I'm going to do it fast. I don't have much time. Y sine of x squared equals x sine of y squared. Oh, wow. Okay, this is going to be a mess. I'm going to take derivative of the left and right hand sides. So please recognize you have a product right here. You have a product right here. So let me try and do it. I'm going to take the derivative of this with respect to x. What's derivative of y with respect to x? It's just dy dx times the second function. So I'm doing product rule. I hope you realize that. Plus, now the derivative of this one. Now, that just has an x in it, so it's a standard derivative, but I have chain rule. The derivative of sine of something is cosine of that something, times the derivative of what's inside of it, 2x. Done with that, but because we were doing product rule, I have to multiply by the first function. So you have the derivative of this, right? Derivative of this times this plus the derivative, right, of that piece times the y equals, now this is another product, so what's the derivative of the first one? Well, it's just x, right? We're differentiating with respect to x, so that's just 1 times the second one plus, now the derivative of the second one, which is this one. Derivative of sine of something is cosine of that something. Chain rule times the derivative of what's inside, which is 2y. But because we're differentiating with respect to x, I now have to say, this right here was the derivative of y squared. What's the derivative of the base? What's the derivative of y by itself? Well, that's dy dx. And now I have finished off the chain rule on that part, but then finish the product rule off times x. Whew. All right. Let's see, this is all one term, and this is all one term. Those are the terms that have dy dx in them. I'm going to move those to one side. So dy dx, sine of x squared. When I bring this whole thing over, it's going to be minus. Now I'm going to move all of this stuff out front. So I'm going to go 2xy instead of yx, that's fine, times dy dx times cosine of y squared. Okay, that's all of that moved over. Equals, now on this side I had sine y squared, but I have to move this piece to the right because it doesn't have a dy dx. So it'll become minus, and I'm going to write 2xy cosine x squared. Now both of these have dy dx in them, so I'm going to factor a dy dx out, and I'm going to do a shortcut here. I'm going to factor that out. Just remember that's multiplication. And then when I factor it out, it's going to look like that. And then I divide both sides by this big thing. So if I divide this side by that big thing, I get sine x squared minus, this whole thing together is 2xy cosine y squared. And all that would be left over here when I cancel these out is dy dx. So I get dy dx is this. All right, I will do a little more later on. All right, continuing here. 2.6. Excuse me, this can be loud. And I'm on number 11. All right, we have tangent of x over y equals x plus y. All right, so what I realize is on the left side, when I take the derivative, I'm going to have chain rule. I'm going to do derivative of tangent of something. And then when I get inside, I'm going to have to do quotient rule. And I'm going to recognize that part of the quotient rule has x, part of it's going to have y, so I'm going to have to use chain rule in there. So let me work through it and see what happens. The derivative of tangent of something is secant squared of that something, then times the derivative of what's inside. So I'm going to do quotient rule. It's the derivative of the top times the bottom minus the derivative of the bottom. I just changed notation on you. Let me go back to the Leibniz notation. The derivative of the top times the bottom minus the derivative with respect to x of the bottom times the top all over the bottom squared. That'll finish off the derivative of the left side. Derivative of the right side, since there's two terms, I'm just going to do derivative of each one separately. That. And now over here we have secant squared of x over y times, now the derivative of x with respect to x is just 1 times y, which is y, minus the derivative of y with respect to x, this is our dy dx. And then times x still, to finish off the quotient there, all over y squared. And this equals the derivative of x with respect to x is 1, and then derivative of y with respect to x is dy dx. Let me see what this text is. I'll get to that later. All right, so here we need to isolate this, but there's another one in there. Remember, this secant is being multiplied through here. So I think what I'll do is distribute. Well, let me rewrite this part first. We've got secant squared x over y times, now I can split this into two terms. It's y over y squared, that's the same as 1 over y, minus, and then this over this, which is going to be x over y squared, and then dy dx, like that. So I just split it into two terms, and then it equals 1 plus dy dx. And now I'll distribute this to here and here. So I'm just going to put that out in front, 1 over y, secant squared x over y, minus, now all this in front of that, x over y squared dy dx, times secant squared of x over y, and then equals 1 plus dy dx. Now I had to do that so that I could release this from this parentheses. So there it is. This whole factor is, I'm going to move this whole factor to this side. I'm going to move the 1 to that side. So somebody is texting me repeatedly over and over and over. Let's see, I don't know if y'all can hear that, but dy dx is still on the right side, and then I brought this whole thing over, so now it's positive. X over y squared dy dx secant squared of x over y, like that. All right, both of these terms have dy dx, so I'm going to factor dy dx out. That was the goal. I'm going to be left with the 1 here. Then I'm going to have x over y squared secant squared of x over y. And then on the left side, I still have this, 1 over y secant squared x over y minus 1. All right, now just divide this thing through on both sides, and we're there. So the left side will be 1 over y secant squared x over y minus 1 over this thing over here, which is 1 plus x over y squared, not x squared over y. X over y squared secant squared x over y, and then that equals dy dx. And the book may try and clear fractions here. They may multiply by y squared on the top and bottom. That way this will turn into a y, and then you'll get a minus y squared there. This will turn to a y squared, and when you distribute, the y squareds cancel. So you just got the x part there. But this is correct. We have solved for dy dx. All right, let me just check this to make sure there's nothing majorly important here. Blanca, who's Blanca? All right, 12. Square root of x plus y equals 1 plus x squared y squared. All right, on the left side, we have root of something, which means we have chain rule. We have to take the derivative of the square root of something, which is 1 over 2 roots of that something, times now the derivative of what's inside. And since it's two terms, I'm going to take the derivative of x with respect to x, which is 1, plus the derivative of y with respect to x, which is dy dx. Very important, though, that I have this multiplication in parentheses, because this must distribute through to both. Equals, derivative of a constant is 0, and then here we have a product right there. So I'm trying to work a little faster now. I'm going to do derivative of this times this plus derivative of this times this. Derivative of x squared is 2x times the second function plus the derivative of y squared with respect to x is 2y, so that's the power rule, 2 comes down. Then the derivative of y is tacked on, dy dx, then times the first function x squared. So that's your derivative. I need to free this, so I need to distribute. Here to here is itself, plus here to here, I'm just going to put the dy dx on top of the 2 over root x plus y, and then equals over here 2xy squared plus 2x squared y dy dx. I just slid this out here. And now I have this factor, or that term right there, and that term both have dy dx in them, so I'm going to get them to one side. So how about we move that over to the left side? So I'll have this piece here still. I'm going to move this piece over, so it's going to become minus 2x squared y dy dx equals, now this piece over here needs to come to the right side, and this piece was still there, so 2xy squared, but I'm minusing 1 over 2 root x plus y. Both of these have dy dx in them, right? Right here, so I factor that out. I'm left with 1 over 2 root x plus y minus 2x squared y equals 2xy squared minus 1 over 2 root x plus y. And then I divide this over here on this side. Let me just do that real quick. Shortcut, 1 over 2 root x plus y minus 2x squared y. And when I divide that out, all I'm left with is dy dx. So dy dx is this. And again, the book may go a little further. They may multiply the top and bottom here by 2 root x plus y, 2 root x plus y, like that, because when you distribute there, you get something ugly, but here it cancels. Here it cancels, and then here it's ugly. But they might do that, they may not. 13, I think I'm going to leave you to do 13. I think you can handle it. It's an odd number, so you can check your answer in the back of the book. $17. All right, for 17, they say if f of x plus x squared and then f of x cubed equals 10 and f of 1 equals 2, find f prime of 1. All right, well, we need to find the derivative of this function at 1. They tell us that the function's value at 1 is 2. So it's kind of like we know that at 1, the function's value is 2. we don't really know what it's doing, but we want to find the slope of the tangent line there. So we need to know what the derivative of the function is. We actually need to figure out what f prime is. So from this, here's what I'm going to do. And take the derivative, right? I've got f of x. I can take the derivative straight away. The derivative of f of x is f prime of x plus, now this is a product rule right here. That's multiplication between these two things. So I'm going to use the product rule there. Derivative of the first one, derivative of x squared, is 2x times the second one, which is f of x cubed, plus the derivative of this thing. So we have, you know, my tau, whatever, cubed. The derivative of my tau cubed is 3 times f of x squared. Chain rule says now take the derivative of what's down here. Derivative of f of x is f prime of x. And then times the first function, which is x squared. So I'm finishing off product rule. That must equal, that must equal 0, because the derivative of this side is constant. The derivative constant is 0. So this is it right here. I would now like to know what f prime of 1 is. So I'm wanting to know what's happening at the x value of 1. So I'm going to come in here and I'm going to replace all my x's with 1. So f prime of 1 should, plus, 2 times x, but that's 1, times the function's value at 1 cubed plus 3 times the function's value at 1 squared times f prime of 1 times 1 squared is 1 should be equal to 0. Now we know in the problem they tell us what f of 1 is. We know what those two values are, right? F of 1 is 2. So I can rewrite this now as f prime of 1 plus 2 times 1, which is 2, times, this is 2, 2 cubed is 8, plus 3 times, now f of 1 is 2, 2 squared is 4, so 3 times 4, and then times f prime of 1 times 1 is f prime of 1, so f prime of 1 must equal 0. So let me clean that up a little bit. This is going to be f prime of 1 plus 16 plus, now just multiply 3 times 4 there, 12 times f prime of 1 must equal 0. And we're almost there. Look at, I have 12 f primes of 1, and I have 1 of them. And if I add those two together, that gives me 13 f prime of 1s plus 16 must equal 0. And if I move that 16 to the other side, 13 f prime of 1 equals negative 16, and then divide both sides by 13. F prime of 1 equals 16 over 13. All right, this was number 17. I'm just going to double check in the back. That just seems like a weird answer. Yeah. Oh, sorry, I forgot the negative. Negative, because it was negative 16. All right, number 20. Use implicit differentiation to find the equation of the tangent line. So finally, we're going to find the equation of the tangent line of this curve. X squared plus 2xy minus y squared plus x equals 2. And we're going to do this at the point 1, 2. And I want to know the equation of the line at that point. So we already know to find the equation of the tangent line, we use this. We already know y1 is 2. We know x1 is 1. We just want to know what the slope of this line is. And to do that, we need to actually find the derivative at 1. Right? Find the derivative at 1. So in other words, we need to find dy dx at 1. At x is 1. So we need to find the derivative first. So let's find the derivative. Now I'm going to work very quickly through this. I have, let's see, 1, 2, 3, 4 terms on the left side. I do have a product rule right there. It's this 2x times y. So first, starting with this, derivative of x squared is 2x plus product rule. Derivative of 2x is just 2 times the second function plus derivative of the second function is dy dx times the first function, 2x. Move on, minus derivative of y squared is 2y, but then because of chain rule, times dy dx. And then plus the derivative of x, well, since we're differentiating with respect to x, it's 1. And that must equal the derivative of the right side, which is 0. So what I could do now is I could try and solve for dy dx. But because I actually am looking at a specific point, if I replace my x's with 1s, my y's with 2, I should have a nice equation. My x's with 1 and my y's with 2. Then I should have a nice equation for the derivative at that point. So this is going to become 2 times 1 plus 2 times 2 plus dy dx times 2 times x, which is 1, minus 2 times y, which is 2, dy dx plus 1 must equal 0. If I can solve this for dy dx, I have my answer. So we have 2 plus 4 plus 2 dy dx, that's this, minus this, which is 4 dy dx, plus 1 must equal 0. So let me put my dy dx's together. Those together gives me negative 2 dy dx. And so I've got those. And then now my numbers, 2 plus 4 is 6, plus 1 is 7, so I have plus 7 equals 0. Move the 7 to the other side. Negative 2 dy dx equals negative 7. Divide both sides by negative 2. You get 7 halves. So that means that the slope of the tangent line at this point 1, 2 should be 7 halves. So this should be y minus 2 equals 7 halves times x minus 1. That should be it. Now for number 22, same thing. I know I'm working faster through these, but I'm hoping you've done enough practice with the implicit differentiation right before this and the previous problems that I can work at this speed. X to the 2/3 plus y to the 2/3 equals 4. And the point that we want to look at is negative 3 root 3, 1. Negative 3 root 3, 1. And they even give you the graph of this. We call this an asteroid, like this. That's the graph of that. And so we're going like, this is a terrible graph. We're going like to negative 3 root 3, goes up to 1. We're trying to find the slope of tangent line there. So I already know that the equation of the tangent line is y minus 1 equals m times x minus x1, which would be plus 3 root 3. So that's my equation. I just need to know the slope of the tangent line there. So I need the derivative. So let me take the derivative over here implicitly. All right, this has just x in it, so it's going to be 2/3 x to the negative 1/3 plus, now same thing, take derivative of this, just use power rule, 2/3 y to the negative 1/3, but because this is y and y is a function of x, we say chain rule times the derivative of y, which is dy dx, and then equals the derivative of 4, which is 0. And I actually know what my x is and my y is, right? So let me come in here. I'm going to clean this up a little bit because it's going to be kind of tough to look at. I have 2 over 3 x to the negative 1/3. I drop it down. That's the cube root of x plus this one right here, 2 over 3 cube root of y, and then dy dx equals 0. So I'm going to replace my y with 1 and my x with negative 3 root 3. This is going to be ugly. Really ugly. So this becomes 2 over 3 times the cube root of x, which is negative 3 root 3, and then plus 2 over 3, and then the cube root of the y, which is 1, and then times dy dx equals 0. This is nice because the cube root of 1 is just 1, so this just becomes 2/3. That one not so nice. But what I'll do is I'll move this to the other side first. So when I move that to the other side, it'll become 2/3 dy dx equals, that to the other side is negative 2 over 3 cube roots of negative 3 root 3. And then I'm gonna get the dy dx by itself. I'm gonna multiply by 3/2 and multiply by 3/2 like that, so that this right here will just become a 1, and we get dy dx is equal to, and then over here the 3 cancels with this 3 and the 2 and the 2, so I have negative 1 over cube root of negative 3 root 3. And I really don't know if I should mess with this anymore. Let's try and mess with it. I don't like that as a slope. So let me try and convince you of something. This negative 3 root 3, that is the same as negative square root of 9 root 3, because 3 is actually the square root of 9, right? I know that looks weird that I do that, but now I can put those back together. This is negative root 27, right? Which is the same as negative 27 to the half, right? That's what that is. But see, I'm supposed to be taking the cube root of all that. So what happens if I take the cube root of all this, the cube root of all this, the cube root of all this, and the cube root of all this? Well, what I could do, I could rewrite this as negative 27, right? Now 27 is to the 1/2, right? The negative is not raised to the 1/2, it's just to the 27. And then I'm doing all of that to the 1/3. And so many different ways you could look at this. If I multiply those two exponents, I get 1/6. So negative 27 to the 1/6, that would be an answer. Another thing you could do is you could rewrite this as negative 27 to the 1/3 to the 1/2, like switch the order. It doesn't matter which order you do those in. And this means cube root of 27. The cube root of 27 is 3. So this is negative 3 to the 1/2, and that's just negative square root of 3. I like that. I like that a lot. Let's go with that one. So we have here that this turns into negative 1 over this whole thing, which we said was negative root 3, which is just 1 over root 3. And if you rationalize, multiply top and bottom by root 3, you get root 3 over 3. And it seems like there would have been an easier way to get to that. I might be working too hard. That's our slope though, and that goes right here. Root 3 over 3. All right, number 25. Find the second derivative. All right, so this is going to get a little bit weird, all right? I'm going to use a different notation here. Please understand that when I'm doing this, number 25, please understand when I'm doing this, that y prime equals dy dx. All right, that's the assumption. That's what I mean by y prime. It means the derivative of y with respect to x. And I'm going to do 9x squared plus y squared equals 9. 9x squared plus y squared equals 9. And I would like to find y double prime. All right, so let me take the derivative implicitly. Derivative of this with respect to x is going to be 18x. That's straightforward. Here, the derivative of this, the 2 would come down because y depends on x. It's 2y, but then times dy dx. But I'm going to write y prime instead. And just understand that means the dy dx equals derivative of 9, which is 0. Now at this point, I can solve for y prime, or I could just take the derivative again. And I think that's the way I'm going to do it. I'm just taking derivative again. So what is the derivative of this right here with respect to x? That would be 18 plus, now I'm taking derivative of this. I have a product rule, so be real careful here. What is the derivative of 2 times y? Well, 2 is going to come along for the ride. And then the derivative of y is y prime times the second one, y prime again, plus now the derivative of the second one. The derivative of the derivative is the second derivative, then times the first function, 2y, then equals the derivative on the right side of 0 is still 0. So please understand, this right here is the product rule on this. 18 plus, now y prime times y prime is not y double prime, that's y prime squared. So I'm going to write y prime squared, and then plus 2yy double prime equals 0. I'm trying to solve for y double prime. So I'll take this and this. Well, let me just move that to the other side. 18 plus 2y prime squared equals negative 2y y double prime. So just subtract it on both sides. I'm going to divide both sides by negative 2y now. I could do it like that if I wanted to. Or I could just do one long bar. Let me do one long bar and just do one down here, negative 2y. And so what we have is that y double prime equals this divided by this, the 2, this turns this into a 9, that turns that into a 1. So I should just have 9 plus y prime squared over, this right here was negative y down here, negative y. Now I'm sure that that's okay. I wonder if they go and do more simplification. They probably do. Let me do this. Let's solve for y prime on this one so we can plug it in up there. So if I solve for y prime, I get 2y y prime equals negative 18x. I'm moving the 18x to the other side. If I divide by 2y, so under here 2y, under here 2y, I get y prime equals 9x, negative 9x over y. And for the bottom here, I need a y. So I could solve this for y by moving this to the other side and then taking the square root. And you can get plus or minus 9 minus 9x, 9 minus 9x squared. So now let me try and rewrite this. This will be equal to, y double prime will be equal to 9 plus y prime, which is this, but squared. So square the top and bottom. You should get 81x squared over y squared over plus or minus the square root of 9 minus 9x squared. And that does not look like a pretty thing. Let me see. 25, 26. Whoa. What am I missing here? Y double prime. Mm, 18x, 9, 0. That's right. And then we had 18. The answer in the back is so much cleaner than this. Wondering, do they clean this up? Okay, let's do this. Let's do this. Let's not replace this y. Let's just leave this as negative y, like that. Okay, now let's get a common denominator on the top. This is going to be 9y squared plus 81x squared over y squared. That's a common denominator on top right there. Then all of this over negative y. And then notice on the top, if I factor out a 9, this will be 9, and then it'll be y squared plus 9x squared. So tricky. Over y squared, and then all of that over negative y. But what is 9x squared plus y squared? 9x squared plus y squared is actually 9. So this thing right here is just 9. So what we get is y double prime equals 9 times 9, 81, over y squared, over negative y, which I can write as a fraction. And then when you flip this like this, you get a final answer of y double prime equals negative 81 over y cubed. Interesting. I believe all of these problems work that way. So I believe I'm going to let you try 27 on your own and 29. However, hi, do you need this?
Can I?
Yeah.
Are you free?
Yeah, no.
Just I can interrupt you, but I hate
Yeah, I told him anytime. I was just saying like they're going to finish the rest of this on their own. So
okay, no worries.
I'm good.
I had to be at 2.
2?
Mm-hmm.
Okay. Oh, so I have 5 minutes? It's 1:40. So I'm okay for 5 minutes? Okay.
Yeah,
All right, good.
thank you, sorry.
All right, no, it's fine. Okay, I'm going to let you do 27 and 29 on your own. I'll do 26. Trying to find y double prime. Square root of x plus square root of y equals 1. And, all right, here we go. Derivative of root x, 1 over 2 root x, plus derivative of root y is 1 over 2 root y. However, you have to take derivative of what's inside, and derivative of what that is y prime. So there's your chain rule, equals 0. All right, I do not like this, because I have to take derivative again. So let me rewrite this back with powers. All right, let's do it that way. So I just brought these things up as rational exponents. Now when I take my derivative again, the negative 1/2 comes out. I get negative 1/4 x to the negative 3/2. And then when I do derivative here, I have a product rule. So I do derivative of the first one. Be real careful here. Derivative of the first one, the negative 1/2 drops out. That's going to be minus 1/4 y to the negative 3/2. But you have to take derivative of what's down here too, because it's chain rule. Derivative of that is y prime, and then times the second one, y prime again. Then finishing product rule plus the derivative of the second one, derivative of y prime is y double prime, and then times the first one, which was 1/2 y to the negative 1/2. And that must equal 0. What a disaster. What a disaster. So let me see if we can't clean this up. This looks really, really bad. Let's get the y double prime term by itself. So this is 1/2. I'm going to rewrite this right here. Actually, I'm going to write that as 1 over 2 root y. That's this piece right here. Times y double prime equals, now I'm going to move this to the other side. So 1 over 4 x root x. So what I did was I dropped this back down and I did the square root of x cubed, gives me this. Bring that one to the other side, plus 1 over 4 y root y, same story. But I have attached to that y prime squared. Wow. Okay. Let's try and get y double prime by itself. Let's multiply both sides by 2 root y. Top on the top here. 2 root y over 1. Same thing over here. So when I do it here, it goes away. I have y double prime equals, now I'm multiplying this one by 2 root y and this one by 2 root y. And we will get, let's see, a root y over 2x root x. That's what that simplifies to be. Here, the root y's cancel. I get plus 1 over 2y y prime squared. And I'm really hoping I can like do something with this. Let's try this. What was y prime? Let's go back over here. Let's figure out what y prime was. I do 1 over 2 root y prime equals, move that to the other side, negative 1 over 2 root x, and then multiply the reciprocal on both sides. It goes away here. I'm multiplying a 2 root y here. 2's cancel. I'm getting y prime is equal to root y over root x, but negative. And if I put that in right here, right, and square it, I'm just going to get y over x. And the y's cancel. And so that leaves me with y double prime equals root y over 2x root x plus 1 over 2x. And so what I can see here, I can get a common denominator. I can put a root x up here and a root x down here. I know I'm working fast. They're kicking me out of this room. So now I have a common denominator. If I put these two together, I get root y plus root x over 2x root x. But I know that root x plus root y is 1. So I get 1 over 2x root x. Okay, I gotta go. That was cool.